So let's jump into an example. Here we need to determine the maximum and minimum values of the following. Sine theta, straightforward. We know that sine theta fluctuates between 1 and -1, so its minimum is -1 while its maximum is 1. 2 sine theta, we have now stretched the sine graph vertically. We've made its amplitude 2. So this original sine theta has become 2 sine theta. We've basically multiplied every single y value with 2. So what we do in the middle of the inequality, we must do on the left of the inequality, and we must do on the right. So I've multiplied every little part of that inequality with 2, and that shows us that our minimum is now -2 while our maximum is +2. What if we now put the 2 next to the theta? We have compressed this graph horizontally, which means we have changed nothing about its minimum and maximum values. Minimum is still -1 while maximum is still +1. However, if you take sine theta and you shift it up by 2, it means you shift the maximum value up by 2 and you shift the minimum value up by 2, turning the maximum value from 1 into 3 and the minimum value from -1 into +1, because we've added 2 to the minimum and maximum value. What about this one here, sine squared theta plus cos squared theta? We have no idea what that graph looks like. However, we know that sine squared theta plus cos squared theta is the square's identity. So this all boils down to an actual constant value of 1. So this graph would be a straight line, horizontal line, going through y equals 1. Therefore, there are no turning points, so there's no maximum and no minimum. What about sine squared theta minus cos squared theta? Aha! Well, here is where we are going to have to apply our identities knowledge. Doesn't this look really, really similar to the cos double angle identity? If we factorize a minus and change the order of the subtraction, we can get a negative cos 2 theta. Now that negative in front of the cos 2 theta merely means it's been reflected, but it hasn't been stretched in any way because the amplitude is still 1. So negative cos 2 theta still lies between -1 and +1 on a graph, and so its maximum value would be +1 while its minimum would be -1. What if we have to determine the value, the maximum value of this relatively complicated looking question? Well, the blue rectangle over there is your clue. You need to know the square's identity. Let's apply it. What if we take sine squared theta and we decide to replace it so that we're dealing with one trig ratio? At the end of the day, that's the goal. Deal with one trig ratio, and then you only have to consider the maximum or minimum value of one graph. So I'm going to now make sine squared theta the subject of the formula in the blue rectangle, and you'll see that sine squared theta is just 1 minus cos squared theta. So we can replace that and then distribute our 3. That will give us 4 cos squared theta plus 3 minus 3 cos squared theta minus 1. Let's simplify our like terms, and we end up with 1 cos squared theta plus 2. Now that is something we can work with, because on the very first slide we wrote down a note about the maximum value of cos squared theta. Cos squared theta fluctuates between 0 and 1. So if we add 2 to the middle, we add 2 to the left, we add 2 to the right, and you can see that the maximum value for this would be 3. Right, that's me for the day. I'm going to leave you to do exercise 4.12, number F and G. There are some tricky ones. Refer to the memo if you need to, but otherwise contact me and let me know how things are going. Thanks, guys. Give yourself a pat on the back. You made it through most. 99% of trigonometry is done.